Hello friends, today we will discuss basic but very important concept from the chapter time, speed and distance. These basic concepts can be used in questions based on trains, boats, races, clocks, relative motion in a straight line, circular motion and various chapter of maths. And friends, you can also find a lot of questions from this area in a various competitive exams. So friends, your ability to solve these problems will totally depend on your detailed understanding of the basic concepts. So please be careful and attentive while going through the concept of the chapter. Now let's start with the chapter time, speed and distance. Now let's have a overview of the session. In this session, first of all, we will do formulas of time, speed and distance. After that, we will do conversion of units, then relation between time, speed and distance, and then average speeds concept, and then in the end we will do some practice questions and their answers. Now let's start with the formula distance equal to speed into time. As we are aware, distance is equal to speed into time, and from these this formula we can also derive another formula like time is equal to distance upon speed and speed equal to distance by time. And friends, you can also apply these formula consciously or subconsciously in a day-to-day life. Suppose you are going to Delhi with a friend in a car and your friend asks how much time we will take to reach Delhi. Then what you used to do? Suppose it comes in your mind that the distance is 250 and we are moving with the speed of 50 km per hour average. So what you say? We will take approximately, you can say 5 hours to reach Delhi. Subconsciously, what you have done, you have applied the formula time is equal to distance by speed. You have taken the distance 250 and the speed is 50, so time will be distance by speed. So these are the basic three formulas on which this chapter is based. Now move to the question. A child goes to school with a speed of 2 km per hour and he takes 4 hours. Find the distance. A child is moving to school and speed is 2 km per hour and he takes 4 hours. Speed is given students 2 hours, time is given 4 hours. So what is the distance? As we have already done, distance is equal to speed into time. So what is speed? Speed is 2 km per hour and what is time? 4 hours. Units are same. So what is 2 into 4? It will be 8 km. So distance will be 8 km. Very basic question, application of the direct formula. Now move to next question. Question number 2. Ramesh covers a distance of 480 km in 20 hours. Find his speed in kilometer per hour. As we are already aware, speed is equal to distance by time. Speed is equal to distance by time. And what is distance here, students? It is 480. So distance here is 480. And what is time? 20 hours. So distance is 480 km, time is hour. So speed will be ultimately, we will cancel, it will be 24 km per hour. So again, application of same formula, distance equal to speed into time. So speed will be distance by time and so on. Now move to, in this slide we will do the conversion of the units from kilometer per hour to meter per second. 1 km per hour. Now I will explain on the slide 1 km per hour. What I have done, I have written 1 km here upon 1 hour. In 1 km how many meters are there, students? In 1 km there are 1000 meters. And in 1 hour, 60 into 60, 3600 seconds. So you can say 1000 divided by 3600. So if you cancel, it will become 5 by 18 meter per second. So straightway, instead of doing this, you can learn straightway. You can write a note. If you want to convert kilometer speed from kilometer per hour to meter per second, then multiplying it by 5 by 18. Multiplying it by 5 by 18. Suppose if I say examiner ask you, or in a question it is an indirect application like 72 kilometer per hour, and we have to convert it into meter per second. So what we will do, 72 into 5 by 18, it will cancel, so it will be 20 meter per second. Clear? So tables can also help you. You have to learn tables from 12 to 19 if possible, because all these tables can help you in maths regarding multiplication, division. Suppose if I say 108 kilometer per hour, students, so it will be 108 into 5 by 18. It will be 30 meter per second, because 18 into 6 will be 108. So it will be 30 meter per second. Clear? Now next slide. Again same, convert meter per second to kilometer per hour. Again same thing, 1 meter per second. 1 meter divided by 1 second. In 1 meter, how many kilometer will be there? 1 by 1000. In 1 second, how many hours will be there? 1 upon 3600. So 3600 divided by 1000, it will be, when we will cancel this, it will become 18 by 5 kilometer per hour. So again, like in previous question, we have to learn, if we want to convert kilometer per hour to meter per second, it is 5 by 18. And here, if we want to convert speed from meter per second to kilometer per hour, multiplied by 18 by 5. Like simple example again, if I say 35 meter per second, and we have to convert this into kilometer per hour, so it will become 35 into 18 by 5. It will be, what is 18 into 7? If we are aware about table, it will be 126 kilometer per hour. Clear? So 5 by 18 and 18 by 5 is very important figures. We have to learn them. There is no need to prove. Okay, now come to next question. Question number 3. A car is moving with a speed of 54 km per hour. It will take how much time to cover a distance of 300 meter? Now what examiner is asking? Time. And as we are already aware, what is time is equal to distance by speed. What is time, students? Distance divided by speed is the time. And what is distance given? 300 meter. What is distance, students, given? 300. And what is speed given? 54 km per hour. This is 300 meter and this is 54 km per hour. Now in maths unit should be same. So convert either meter per second, so meter into kilometer per hour, or you can say convert kilometer per hour into meter per second. And already we have done 54 km per hour into meter per second. So what we'll do? Multiply by 5 by 18. So it will be 15 meter per second. And now unit is 15 meter per second. After that what you will do? Distance is given 300. Speed is given 15 meter per second. So what will be time? It will be 20 seconds. Answer will be in seconds. So it will be 20 seconds. So time will be 20 seconds. So here what we have learned? Conversion of the units. 54 km per hour to meter per second, which is 15 meter per second. And distance is already in meters. So we have to take care of the units also. Clear? Now we will move to next question. Radha and Meera covers a distance of 720 meters in 18 seconds and 24 seconds respectively. Find the difference between their speeds in kilometer per hour. Okay. Here examiner is asking difference between speeds. Kilometer per hour is the important thing. Unit is in kilometer per hour. But now in the question it is given 720 meter, 18 seconds and 24 seconds. So what we'll do? Speed is equal to, as we know, speed is equal to distance by time. Now I will take For Radha, (720) speed will be distance 720 and time is 18 seconds. So for Radha, speed will be 40 meter per second. And for Meera, again distance is same, students, 720 and time is 24 seconds. So for that it will be 30 meter per second. Now we have find their speeds 24 and 30 meter per second. The question is find the difference between their speeds. Find the difference between their speeds. Now what is the difference? Difference is 40 minus 30, which is 10 meter per second, and question is we have to convert it into kilometer per hour. So again we are aware 10 multiplied by 18 by 5. If we want to convert from meter per second into kilometer per hour, then it will be multiplied by 18 by 5. So it will be 36 kilometer per hour. So our answer is 36 kilometer per hour is the difference of their speeds. Clear, students? Again, what we have learned here, conversion of the units. Initially distance is meters, time is in seconds, so speed will be meter per second, and after that again we have applied the same formula. Now move to next slide, relation between speed, time and distance. Speed and distance are directly proportional when time is constant. Similarly, time and distance are directly proportional when speed is constant. Speed and time are inversely proportional when distance is constant. First of all, what does it mean? Speed and distance are directly proportional when time is constant. I will take example. Suppose we are moving with the speed of 30 kilometer per hour, 30 kilometer per hour, and you are taking 4 hours. Time is 4 hours. Speed is 30 kilometer per hour. Time is 4 hours. So how much distance you will cover? Speed is 30. Time is 4 hours. So distance will be equal to 30 into 4. Students, it will be 120 kilometer. Okay. Now, if I increase my speed, suppose if I increase my speed from 30 to 90, now my speed is 90 kilometer per hour. 90 kilometer per hour. Initially it was 30. Now I've increased speed from 30 to 90, and time is same. Third thing should be constant. Time is 4 hours. Time is 4 hours. If I'll increase my speed from 30 to 90, that means I've tripled my speed. That means again distance covered will be tripled. Initially we are covering distance as 120, and now distance will be 120 into 360, because speed and distance is directly proportional. If one thing will increase, other will increase. If one will fall, other will also fall. And you can also apply formula, distance is equal to speed into time. Now I've increased speed from 30 to 90, and time is again, students, same, 4 hours. So distance covered will be 360. You can see speed is 3 times, distance is 3 times, from 120 to 360. But this will only applicable if the time is constant. Third thing should be constant, students. So you can apply this formula in other area also, like time and distance are directly proportional when speed is constant. More time, more distance if speed is same. Less time, less distance if speed is same. Now let's do some questions based on these formulas. Okay. Walking at 4/5 of his usual speed. What does it mean? 4/5 of his usual speed. Like if my speed is s, so if I move from s to 4/5s. Walking at 4/5 of his usual speed, a turtle is 20 minutes late to his way to pool. Find the usual time taken. This is important. Find the usual time taken by the turtle. As students, we are already aware distance is equal to speed into time, or you can say time is equal to d upon s. Time equal to d by s. Now in the question it is given walking at uh, walking at 4/5 of his usual speed. If I'll say d upon, let his speed is s, his speed is s, walking at 4/5 of s. If he is taking initially t time and he is late by 20 minutes, so now he will take t plus 20. I think that this is clear to everyone. What I've done, I've applied the formula time equal distance by speed. Now his speed is 4/5 of s, so time will be t plus 20. So in next step, 5/4 d by s is equal to t plus 20, and as we are aware, what is d by s? What is d by s? D by s is t. So what we'll do, we will put 5/4, instead of d by s we'll write t is equal to t plus 20, and in the next step it will be 5/4t minus t is equal to 20. So t by 4 is equal to 20, and here t will be equal to 80. And what is t? Usual time taken. We have taken t as a usual time. So our answer is 80 minutes. 80 minutes. Simple, we have applied the formula distance equal to speed into time, or now we have to see, we have to write s equal to d by t, or t equal to d by s, and where the equation will be easy, we will write by that way. Now we will move to the next question. Based on again same concept, motorcycles at a speed of 7 km/h and reaches the park 8 minutes late. Next time he increases his speed by 1 km/h and reaches 7 minutes early. Find the distance from house to park. Motorcycles at a speed of initial, and we have to find distance, and we have given speed is given and time is also given. So distance by speed is equal to time. Same formula we will apply. Suppose let distance is equal to d. Students, let distance equal to d. Walking at d by 7, distance by speed is time. If initially he is taking t time, now he is late by 8 minutes. Now he is taking t plus 8. T plus 8. Now here it is given distance, I have taken d kilometer and speed is 7 km/h and time is 8 minutes. Now convert this 8 minutes into hours. We will divide it by 60. 8 by 60. Next time he increases speed by 1 km/h. D upon initially speed is 7 and now his speed will be 8 because increases speed by 1 km/h. D upon 8 is equal to t, and by doing so he reaches 7 minutes early. That means if he is taking t time, he will be there by t minus 7 by 60. And if we deduct these both equations, so it will be d by 7 minus d by 8, t will cancel, is equal to 8 plus 7, 15 by 60. It will be 15 by 60. So in next step, d by 7 minus d by 8, LCM will be 50. LCM will be 56. 8d minus 7d is equal to 15 by 60. D upon 56 is equal to 1 by 4, and here d will be equal to 14. So what will be, students? D 14, and unit should be kilometer, because we have taken that distance equal to d. Here you can write kilometer. because speed is 7 km per hour. So distance will be d kilometer and d is 14. Now we will move to next question. And the next slide is slide on average speed. Average speed is equal to total distance by total time. As students, we are already aware speed is equal to what is speed? Distance by time. We are already done. So what is average speed? Total distance by total time. So one note is given, if a certain distance is covered at x km per hour and same distance is covered at y km per hour, then the average speed of the whole journey will be 2xy upon x plus y. We will prove it in the later on stages at the question. Now come to the question. When speeds are different and distance are different. Now students, just go through the question. A man covers the first 180 km of his journey from Chandigarh to Jaipur at a speed of 60 km per hour, then next 120 km at a speed of 40 km per hour, and remaining 240 km at a speed of 60 km per hour. What is average speed of the entire journey? As we are already aware, what is average speed? Average speed is equal to total distance upon total time. And now we have to find total distance. Distances are given 180, 120 and then 240. Total distance is given and we have to find the total time. And speed is also given, so we can find total time. Now in first case, distance is 180, distance is students 180 and distance is 180 and speed is 60. So what will be time? Distance by speed will be the time. It will be 3 hours. It will be students 3 hours. In second case, what is distance? 120 is given. So what will be time? Distance 120 given and speed is given 40 divided by speed. It will be again 3 hours. So in third case, what will be distance given? Student 240 and with 240 what is the speed? 60. So 240 by 60 it will be 4 hours. So total time it will be 3 plus 3 plus 4 which will be equal to 10 hours. And now total distance is total distance is equal to 180 plus 120 plus 240 which will be 300 plus 240, it will be equal to 540. Now we are aware total distance, we are aware total time. So what is average speed? Total distance by total time which will be 54 and answer should be kilometer per hour. So it will be 54 kilometer per hour. Now move to the next question. I think that this question is clear. Average speed, what we have to do? Just read the question, see what is given and then apply basic formula. Speed equal to distance by time, time equal to distance by speed, and average speed is equal to total distance by total time. Now next question is, when speeds are different, time is different. Just go through the question, students. Now Vijay travels his first 3 hours of journey at a speed of 60 km per hour. Next 4 hours 65, remaining 8 hours speed of 70 is average speed. Again same formula, average speed is equal to total average speed is equal to total distance by total time. And now what is given? time is given 3 hours initially and with speed of 60. So distance will be equal to 3 into 60. It will be 180 for the first case. Next 4 hours at a speed of, for next 4 hour, time is 4 hour and speed is 65, and the distance will be 4, 5, 20, 4, 260 kilometer. It is kilometer, students. And in the last case, distance will be, students, time is 8 hours and speed of 70. So distance will be 8 into 70, 560 kilometer. And it will do total. So total will be 0, 6, 6, 12, 8, 20, 0 carry 2, 10. Total distance will be, student, 1000 kilometer. Now we have got the total distance 1000 and total time is given 3 hours plus 4 hours plus 8 hours. What is total time, students? Total time is given 3 plus 4 plus 8, which will be 15 hours. And what will be the answer? Now total average speed is equal to total distance by total time. And what is total distance? 1000. What is total time? 15. And it will be 200 by 3, which will be equal to 66 2 by 3 kilometer per hour is the average speed of the entire journey. Again, student, what we have done? We have again done the application of the basic formula. Total distance by total time. Now come to next question. When speeds are now just go through the question, students. Amit went to Delhi at a speed of 50 km per hour and came back with a speed of 100 km per hour. Find his average speed for the entire trip. Again, as we are aware, what is average speed? Total distance by total time. Now, if I say let distance is equal to d kilometer. Amit went to Delhi at a speed of, speed is given 50. Now we have to find total time. Distance by speed is time. If he is going to Delhi with the speed of 50, so time taken will be distance by speed, and came back with the speed of 100 plus distance by 100, it will be equal to total time. Total time, students. And it will be equal to LCM will be 50 into 100. I will write straightway here. 50 into 100, 100d plus 50d, which will be equal to 150d upon 50 into 100. This is equal to total time. This is equal to, students, total time. And what is total distance will be? For going and coming, it will be 2d. Because distance will be d kilometer, so total distance will be total distance is equal to 2d, d plus d. And after that, we will apply the formula. Average speed is equal to total distance by total time. And what is total distance, students? It is 2d. And what is total time? Divided by 150d upon 50 into 100. It will be equal to 2d upon 150d into 50 into 100. dd will be cancelled. So answer will be from 0 to 0 it will be cancelled, so answer will be and from this 5 3 15 5 to 10, so again it will be 200 by 3, which will be equal to 66 2 by 3 kilometer per hour. Again students, if simply we are aware about the formula which was given in the initial concept, when the distance is same but the speeds are different, what you can do, you can straightaway apply formula average speed will be 2xy upon x plus y, where x and y are two different speeds. So if you put here 2 into 50 into 100 upon 50 plus 100, it will be the same thing which we have already done here. So again answer will be 2 into 50 into 100 divided by 150, it will be 200 by 3, again which will be equal to 66 2 by 3 kilometer per hour. So you can apply this formula when speeds are different and the distance is same. Now we will move to the next slide. These are some practice questions, students, which you have to do at your own place. Just go through the questions. Just have a look. And these are 2 questions on this page. And now there are next 2 questions on another page. Question number 3 and question number 4. Boy goes to school, speed of 9 km per hour. Very basic questions, again based on same concept which you have already done. And these are the answers for these 4 questions. 3 hours, 720, 18 and 100 minutes. Now thank you students. Have a happy learning. Okay.